David Smith here with another Flip Classroom math lesson. 3 tips before we start. Remember that you can adjust the playback speed if that helps you work through the video. You can also pause the video at any point to take notes or jot down questions. Lastly, you can turn on the captions so you can read my words go by on the screen. Today's topic, trigonometric equations. So we're going to do some setup at first to get into those equations, including a key concept here that relates back to the unit circle. So if two angles have, there's an E there, have the same sine or cosine. Now before I go on, let's talk about what that means. Two angles have the same sine. They could be different angles, but if you put it into the calculator, you're going to get the same value for sine. Or if you look on the unit circle and you go around to wherever that angle hits, they're going to have the same sine. So if they have the same sine, then they have the same y coordinate. Okay? And that's because we know that the coordinates of points going around the unit circle, the x coordinate is cosine of the theta and the y coordinate is the sine of the theta. So, if they have the same cosine, they're going to have the same x coordinate. Okay? All right, so now let's take a look at that on the unit circle over there. Let's go back to sine. Remember, sine is the y value, so let's throw some theta on here. Here's a theta. This is x, y, right there. Y is sine theta. So, is there another angle that gives us the same value for y or for sine theta? There sure is. Well, there's a bunch of them, but the next one is right there. This angle here, this is also x, y, and y is also the same value as here because we are going up that distance and we've gone up that distance, okay? So these two angles, so this theta here versus that theta there, if this was like theta 2, it's going to be a different angle, but it's going to give us the same value when we plug it into the sine function, or the same y coordinate. Okay, so this is an example using the unit circle of showing how if they have the same sine, they have the same y coordinate. Now let's do that on the unit circle with an x coordinate. Let's do the same kind of thing to start. Here's our point, here's our theta, and now we have our xy there, and we know that the x coordinate is cosine theta. Okay, so think about that for a minute. Where is the other angle that has the same x coordinate? Okay, that would be down here. Right there, and this would be also xy, and so we've come around all the way to here, like some theta 2, so it's not the same as theta, but we know, because these are the same x values there, that these are going to have the same x coordinate. So that shows on the unit circle how this is true. Let's look at tangent. Okay, so tangent's a little bit different than sine and cosine. So tangent, what we're going to get to is that if two thetas have the same value, so if tan of some angle has the same value as tan of another angle, then the two angles have to be 180 degrees apart, okay? And let's dig into that. So here's my unit circle with my theta, and we know that the coordinates of this point are x and y, and then we know that x is cosine theta and y is sine theta. So this is the basics that we've been using quite a bit in this unit. And then a few lessons back, we showed that tan theta is sine theta over cosine theta. This is a trigonometric identity that's always true for any theta. Now we can go backwards. We know that sine theta is y, so tan theta is y over x. X is cosine theta. So tan theta is this ratio here, okay? Now that's x and y, okay? So where would this thing be the same in the unit circle, okay? So we can go around to here, and this would be negative x positive y, but that's not going to give us the same value. But if I go a whole 180 degrees, all the way down to here, this is going to be negative x, negative y, right? Because this is all silly turtles. So tangent is positive, but sine and cosine are both negative here, so that's why this is negative x and negative y. But we know that negative x divided by negative y is the same thing as, negative y divided by negative x is the same thing as y divided by x, which is what we have here. So what that shows us is that if you want the same value for tan theta, you just have to go another 180 degrees around the unit circle and you'll have that same value. Let's do some problems. These get a little tricky and you're going to need to consult your unit circle. So you might want to have that handy. Okay, so here's a type of a problem that you might see. Solve for theta. So you're being asked to find the value of theta. Now most commonly, you're going to have to find your answer in radians, and that indeed is what we're going to do in this problem. Okay, it also gives a range, all right? So, because we can go around the unit circle forever, and so we can find lots of values of theta that will satisfy this equation that we've got. We only want the values of theta that occur between 0 and 2 pi radians. Remember, 2 pi is all the way around the circle. So looking at our unit circle over there, we only want the values of theta that fall in one turn around the unit circle. Okay, so here's our equation. Sine theta is root 3 over 2. We need to find out what theta is within that range. Now, it's useful to know the decimal approximations for some of these, just so that we can figure out where we are on the unit circle. Okay, now I might write a test or a quiz question that asks you to generate this unit circle diagram, even if I don't. Drawing the unit circle really helps you orient to these problems and know what you're doing. Okay, let's take a look at where this is. Okay, so we know sine theta, root 3 over 2, that's the y-coordinate, that's the distance above the x-axis on our unit circle, and root 3 over 2 is about 0.87, so we know it's pretty far up, it's almost to 1. 0.87 is like 0.9, so I'm going to say that level is somewhere around there. Okay, so that gives us this point with this theta. Okay, so the y-coordinate is root 3 over 2 here. So now what I'm going to do is pull out my unit circle right here and take a look and see where the y-coordinate, which is sine theta, is root 3 over 2. And I can tell from my unit circle that it's at 60 degrees or pi over 3 radians. So this is 60 degrees, which is pi over 3 radians. I'm going to use that little c to indicate that that's radians. So that's one point. We also have this point over here. So we've come a little further. Different theta, but since we're still above the x-axis, we're going to have the same value for sine theta. So let's take a look at that. Pull up my unit circle. Now I'm going further past, and I can see that root 3 over 2 happens at 120 degrees, which is 2 pi over 3 radians, and that's right here. So let's say theta 2, that one is 2 pi over 3 radians. Okay? So those are the two values of theta in this range when sine theta is root 3 over 2. So we could say it's pi over 3 and 2 pi over 3 radians. Okay, let's try a different problem. Now we're going to solve for theta, and now we have this expression, a little more complicated. You're going to have to do a little bit of algebra to it to get it to a point where you know what's going on. Because right now we have root 2 times cosine theta equals -1. And so we don't know yet what cosine theta is. Fortunately, I can just divide both sides by root 2 and get cosine theta equals -1 over root 2. Okay, so now we know what cosine theta is. It's negative, so we know it's going to be on the left side of the y-axis. Pull up my handy-dandy unit circle diagram and take a look. I'm looking for points where the x-coordinate is -1 over root 2. That's at 135 degrees, or 3 pi over 4 radians. So that's over here, and that gives me this point there, with a theta, it's there. And we know that's 135 degrees. Forgot the radians on that. That was 3 pi over 4 radians. Now, with many of these questions, there's two answers that work, because indeed, there are two places on the unit circle where the x-coordinate is equal to -1 over root 2. And that's here with a theta of 135 or 3 pi over 4 radians, It's also down here, again, looking at my unit circle, looking for an x-coordinate that is -1 over root 2, and that's going to be at 225 degrees or 5 pi over 4. So that's this one, my theta 2, which is 225 degrees, which is the same as 5 pi over 4. Okay. So there's two values in the range, I erased my range from the last screen, but we're just going to use that same range. So the range is one turn around the unit circle. There's two values. There's 3 pi over 4 radians, and there's 5 pi over 4 radians. So those are the two angles where cosine theta, which is the x-coordinate, is -1 over root 2. Okay, let's do one with tangent. And this one's kind of complicated. Okay, so just buckle your seatbelt, take good notes, write down questions for class, okay? All right, we're going to solve for theta, but now we have this expression, root 3 times tan theta -1 equals 0. So to figure out what tan theta is, we do need to isolate it on one side of the equation. So I'll do this in a couple steps. Root 3 tan theta equals 1. I added 1 to both sides. And then I'm going to divide through by root 3. I'm going to get tan theta equals 1 over root 3. Now, tangent is not directly indicated on the unit circle because tangent is sine divided by cosine. So you're not going to be able to take a look at your unit circle diagram and find a value of 1 over root 3. It's just not going to happen. But if you look at your unit circle, you're going to notice that there's only certain angles that do have root 3's in them, and they are all the angles that go around in 30-degree increments, okay? So let's take a look at the first two. There's here, and there's there. Okay, so this is 30, and this is 60, okay? So let's take a look at the points that are here, and the points that are there. So at 30 degrees, we have root 3 over 2, comma 1/2. And at 60 degrees, we have 1/2, comma root 3 over 2. Okay? So we're getting there. But we have to remember this. Tan theta is the same as sine theta over cosine theta. So we need to figure out which of these 2 points is going to give us what we want, 1 over root 3. So we have to divide, remember we're looking at sine divided by cosine, so it's the second term, the y term divided by the first term. Which one of those is going to give us the value that we want? Okay, so I'm going to give it a try. I'm going to try my first one with the 30 degrees, with the pi over 6 radians. So if it's 30 degrees, then this should work. I have sine theta over cosine theta. Sine theta over cosine theta is going to equal, so sine theta at 30 degrees is 1/2. Cosine theta at 30 degrees is root 3 over 2. Now this, if I complete the operations, should take us to here if indeed 30 degrees is the right angle. So let's try that. I have 2 fractions divided by each other, so flip and multiply. That's going to be 1/2 times 2 over root 3. And check it out. The 2's cancel, and I get 1 over root 3. So we got it. Okay? If I did it with this other point, this one, I wouldn't get that. I think I would just get root 3, and that's not right. Okay. So, deep breath. We know that one of the angles is 30 degrees or pi over 6 radians. Remember, we're solving for theta. So we did all this work, and we got a theta, we got 30 degrees. Now, if you remember from the last screen, there's another theta that gives you the same thing. And that's 180 degrees away, right there. This is 210 degrees, okay? And this point would be the same as this point but with negatives. So it's negative root 3 over 2, comma negative 1/2. I'm not going to do the fraction work that we did with the other one. Suffice it to know that both of these are negative, so the answer when you divide sine by cosine is going to be positive. It's going to give us the same result as 1 over root 3. So our two angles are 30 degrees and 210 degrees. And if you look at your unit circle, 210, so 30 degrees is pi over 6, and 210 is 7 pi over 6. Okay, let's look at one last find the angle problem. Okay, so here's our trigonometric expression. And we see we've got a cosine theta in here, but we're subtracting 1 from it, and we're also multiplying it by 2. So we have to simplify this so that we get cosine theta by itself on one side. I'm going to add 1 to both sides. So I get 2 cos theta equals 1, divide by 2, cosine theta equals 1/2. Okay? So now remembering, cosine is the x value, so 1/2, it's positive. 1/2 x is right there. Remember, this is 1, that's 1/2. So now I can draw a vertical line through 1/2, and that gives me my 2 points. Right there. Now, I can use my handy-dandy unit circle diagram to figure out what my theta is for that. So when cosine is 1/2, theta is 60 degrees or pi over 3. So this theta equals 60 degrees, which is also pi over 3 radians. Okay? Now this one, going the other way, it's going to be 60 degrees down, but I'm going to use my unit circle just to get a better feeling for that. Because remember, we measured these going counterclockwise all the way around. So I know this is 270, so that's going to be 300. So theta 1 is 60, or pi over 3. Theta 2 is 300. And then, because I don't have these memorized, I'm going to look on my unit circle diagram, and it's 5 pi over 3. Okay? So to kind of summarize what we did in this problem, which is similar to the ones we did just a second ago, we have a trigonometric expression, and we're asked to find the values of theta in the range of theta goes from 0 to 2 pi radians. Okay? So that's the range. That means one circuit around the unit circle. So that's all we have to look at. So then I took my expression, I used some algebra to get cosine theta alone. I found what the value of cosine theta was. That's 1/2. I recognized that cosine theta is the x-coordinate. So then I could plot it on my unit circle. 1/2 is right there. I drew a vertical line because that's where x equals 1/2. And it intersects the unit circle up here and down there. And then I use my unit circle diagram to figure out that that theta is 60 degrees or pi over 3 radians for this one, and that second theta is 300 or 5 pi over 3 radians for that one. Now that you've watched the video, take a minute to jot down notes or questions that you might have for our next class. You can also re-watch portions of the video that didn't sink in the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.